Hello, and welcome to Introduction to Blockchain Technology. This is going to be a brief introduction, about 15 minutes or so, to give you a high-level information about the blockchain technology. Won't go into the depths of it, but just touch the surface at the top of the layer, and just to get the point across for somebody who does not know anything about blockchain, give them some uh, perspective about it. So as we go along during the course, if you guys have any questions, let me know via my website at the bottom of the slide, secunoid.com. All my contact details are there, and if you have any questions, again, you can post them at the bottom of the video. Thank you. I thought before I proceed, I talk about who actually I am and what do I do. So I've been in IT industry for about 25 years. I've done a lot of work around infrastructure design, networking, um, training, and my background is heavily in IT security. So my focus has always been IT security. Um, During the day, I work in security compliance and risk management, and in my spare time, after work is all done, I I dabble with full stack programming using React, Redux, um, sometimes Python, um, and I'm quite familiar with AWS as well. Um, Sometimes I trade cryptocurrencies as well, and write voice applications. Um, how did I get into crypto? So I have been in crypto since 2009. A good friend of mine mentioned this to me while we were having coffee, that there's this new technology called Bitcoin, where people are mining it on on computers, and um, they just making some kind of money, and I got interested since then. I've been following it, and I actively start participating in 2013. That's when I bought my first Bitcoin on online, and I was amazed at how quickly I paid for it via my bank account, and I got the Bitcoin in my wallet. It was pretty quick. Like back then in 2013, systems were pretty quick because there was not a lot of load on the system. And like I said earlier, where can you find me? Um, Here's a website, secunoid.com. So all my blogs, my podcast, um, everything I do is on the site. So contact me through that. If you have any questions, let me know, and we'll try to answer them. Thank you. So what is blockchain? It is a digital ledger in which transactions are recorded in blocks, and each block references the previous block using mathematical functions, hence forming a chain. A digital ledger is not owned by any entity. It replicates to systems on the internet called nodes who have the necessary software to maintain it. To become a node, all you need is a computer with connectivity to the internet and supporting software that can host this particular ledger. For Bitcoin, it is a Bitcoin blockchain. For Ethereum, is that Ethereum blockchain, and every token, every crypto has its own version of the blockchain, and you have to install that particular software to um, support the blockchain. Um, and because it is spread across different nodes, it is a distributed ledger where everything is um, nothing is centrally owned. Everything is on all different computers. As soon as one system updates, it sends all the updates to all the different nodes, and it is this what takes time in terms of making sure that everybody is at the same speed in terms of knowing what transactions have occurred. Blockchain security. So the next item is the blockchain security. Um, to make a block, because it's called a blockchain, it's a chain of blocks, and each block usually is made up of 2,500 transactions. And each of these transactions, what happens is in order to um, form a block, each of these transactions are hashed. So each of these 2,500 transactions are hashed. So two transactions, the first one and the second one, get hashed. The third and the fourth get hashed, and the result of these two hashes gets hashed. And as you go down the tree, that's why it's called a Merkle tree. It's an upside down tree. And as two peer transactions get hashed, the resulting value of their hash is also hashed, and until you end up with one hash. And this is the hash of the block. And once the hash of the block has been calculated, then the consensus mechanism that the at least the Bitcoin blockchain uses is proof of work, where the algorithm says you have to match a number. So this block hash plus a nonce should equal to something, and it is this nonce that the computers which are actually involved in the mining activity are doing. They're trying to calculate this number. They take it the hash and they add a number to it, and they see if it is equal to that number that the algorithm is presenting them with. And if it is within the range of that number, then the block has been created, and that particular miner gets to bring home the money for the for discovering the block. And the moment the block is discovered, it gets echoed to all the nodes, and every node, if they're in the middle of finding the solving this problem, um, they stop doing that and they add this to their blockchain. The other thing that happens is there could be an issue where um, two systems, one out in the East Coast, one in the West Coast, have figured out the block. So once they figure out this block, uh, the way they decide who wins is whichever has the longest chain. So whoever has shared their um, result with the most nodes wins, and the one who doesn't concedes, and um, they continue looking for other numbers. Besides proof of work, there's also another algorithm called proof of stake, which is becoming popular in light of um, the energy that gets wasted when blockchain mining happens. Because every time you do this calculation to match a number, you're wasting electricity, um, and that electricity is causing greenhouse gases and all that kind of stuff, right? So that's why proof of work is causing to be a bit of a mess for the planet. So Ethereum is currently looking into moving into proof of stake. So they were supposed to introduce um, a new algorithm in December 2017, but it was not ready. They're going to do it sometime this year. Tokens versus cryptocurrencies. So if you go to CoinMarketCap, over there you'll see about 12, 1300 tokens listed over there. And the reason I call them tokens um, is because everything that gets produced by a blockchain or distributed ledgers is a token, but it is the function of the token that decides what it is. So a token can be um, predominantly of two different types. So one of the tokens is a utility token, which is Ether, which is used in the Ethereum network. So every time you want to execute a smart contract, deploy a smart contract, you have to spend some Ether to um, buy some gas, and that's how your smart contract operates. Um, and then there's these other tokens which are a store of value, something like a Bitcoin, and which also are called cryptocurrencies. Um, they don't have any function besides um, store of value. Um, and most recently, um, one of the other token types are called tokenized securities, which another platform that launched last year called Gibril was introduced. So what you can do is you can tokenize anything you want. You can tokenize paper. You can tokenize pork bellies or whatever you want to trade on your platform on this Gibril platform. You can literally tokenize it and give it some value. Blockchain platforms. So when talking about blockchain platforms, when Bitcoin was introduced way back, its main function was, and the reason it was introduced was as a value of exchange of money. Um, but you can also store certain pieces of data within the blockchain, and that makes it you know um, pretty secure in there in terms of nobody can update it. So when people start getting new ideas on how to use uh, this this Bitcoin blockchain, they said, how about we build some applications on it that we can use. So every time somebody wanted to build an application on a blockchain platform, they had to write a piece of code that did all kinds of funky stuff, right? All the logic and how do you do it and all the little details. Everything had to be done over and over again from scratch. So this is where Vitalik Buterin, the founder of Ethereum, came about after working on a few projects. He said, I'm going to build a platform which is going to provide you these basic ingredients to build a token, and then which would have something called a smart contract. It is going to have a, a a utility token called Ether, where people could program the blockchain, put the code in it, and utilize it for different functions. And as a result of that, that particular Ethereum deployment became the main platform for all the ICOs that are happening in the world. Um, So if you want to create an ICO, you go to the Ethereum platform. Your token has to be ERC20 compliant, which is a standard that Ethereum says if your token is ERC20 compliant, any wallet that understands ERC20 will be able to use your token. So that's why ICOs are predominantly done on Ethereum. There are other platforms as well. Uh, there's platforms like EOS, Neo, Stellar, Ripple, which are providing similar kind of functionality, but they're for different reasons, right? Ethereum seems to be the most popular one. Stellar is not bad, neither Neo or EOS. Um, and so these that I've mentioned right now were all public um, blockchains. Um, Big organizations like IBM came up with a permission blockchain, which is a private blockchain which can be used on in consortiums, and it is a platform just like Ethereum, Neo, EOS, but it has a lot more flexibility in terms of what it can be used with. You can integrate with a lot of current technologies that you may have in your organization in terms of authentication, authorization, certificate authority. Um, uh, and programming stack, because Ethereum, Neo, EOS, these Ethereum predominantly does smart contracts in Solidity, which is a JavaScript-like language that Ethereum uses. Neo has is also expanding that. They allow JavaScript, they allow C Sharp, they allow myriad of languages to program contracts, the smart contracts, and similar thing with EOS. So Hyperledger is also doing that, but it is more targeted towards organizations, big consortiums where people agree and they decide on their consensus algorithms and mechanisms, and they start working on it internally, and it's like internet versus intranet. When an organization has an intranet, they might have, which is for their own people, and they use it internally, and nothing gets exposed outside. Um, and Whereas the others are, everything's outside and nothing comes back in. So why should we use blockchain? Um, Blockchain is not a solution for everything. Um, there are typical use cases where blockchain would benefit you. If you are about um, saving a lot of history, and that history cannot be changed, then blockchain is your answer. So anything that you do gets to go to the blockchain, and if you want to go play back that whole story, you can go block by block in the reverse order, and you will find the whole history about it. The beauty of blockchain is that um, because it is a chain of blocks, and which have gone through a mathematical function of hashing, you cannot go and delete a transaction from a block. The moment you delete a transaction from a block, you have totally messed up that particular copy of the distributed ledger, and people don't start talking to it. So that's why you just cannot delete anything from the blockchain. So that's one use. Um, um, and there's a primary thing. So if you see any of the blockchains, they are sitting open on the internet, and so far no one has ever been able to hack any of the blockchains. What gets hacked is when you hear stuff about people losing tokens, people losing Bitcoin or whatever, it gets stolen from their wallets. So if a hacker is able to compromise someone's wallet, and the compromise happen when someone doesn't have a secret that is long enough, or they have a secret exposed somewhere, then hacker can go into the wallet and do whatever they want. If there's something in there, they'll take it away. Um, the only other issue with blockchain is, so this is the good part, right? The other part is uh, existing public blockchains are not scalable. When I say it's not scalable, it's is that Bitcoin blockchain is currently capable of 5 transactions per second, and Ethereum is capable of doing 15 transactions per second. If you want like credit card processing, those guys handle a lot more transactions than this per second. So these guys, the existing state of blockchains cannot handle anything like that. So there are projects that are looking at solutions to this problem, off chain or side chains. One of the active projects is Lightning Network that is trying things out, and the other mechanism is um, sharding. So, so guys, that's all I had to talk about blockchains, and I hope this talk was beneficial to you. If you have any questions, like I said, contact me on my website. My contact details are there, secunoid.com. Thank you, and have a good day. Bye bye.